Radhe Radhe. So in this video, I'm going to discuss the minimum array end problem which occurred in today's LEETCODE challenge. So if you have any doubt regarding this, ping me up on Instagram. Even you can join my Discord server. I'll put both the links in the comment section. I'll pin them. Problem statement is very simple. You're given a number n and a number x. That is, you have to find an array where the next integer, the next element is greater than the previous element for every case, and the size of the array should be n, and the bitwise AND of all the elements of the array should be x. Okay, so basically what you can say is, since bitwise AND should be x, so the minimum number which can be in that array has to be the x. Okay, so basically the array would look somewhat like this: x plus a, x plus a plus b, and dot dot dot. Okay, till there are n elements. Now the thing is, you have to find the minimum element which is at the end of the array. So basically you have to find the minimum value of x plus a, the minimum value of x plus a plus b, and the minimum values of a plus b plus c plus d plus whatever it is. Okay, so how we are going to do this? So remember one thing, since we are dealing with AND, so I'll like directly go into the explanation part. So let's do for this one. Okay, so x is equal to 4. So what is the binary representation of 4? It is somewhat 1 0 0. Okay, so let me rewrite it. So 1 0 0. Okay, and what is the binary representation of 3? It is going to be 1 1, right? But remember one thing, since the first element is confirmed, so we just need to find the next n minus 1th term. Okay, after that, so how many operations do we need to perform? N minus 1, because the one among them is x, we know this. So you have to perform n minus 1. So for every case n minus 1 and x, so you have to find the binary representation of it. Okay, so for x in the first case it is going to be 100, I mean 100, and for this n minus 1, that is 2 is going to have a representation of 10. Okay, so once you're done with 100 and 10, so remember one thing, in the place of zeros you have to just replace it with these elements. So that is, when it is at this position it is 0, so it becomes 0. When it is at this position, since there is a 0, we have to replace it with 1, so it is 1, and then there is a 1 over here. So what is the binary representation of this? The binary representation of this is going to be 6. Okay, so simple, so you get the answer 6. So for this, similarly for the next one, so let's do it. N is equal to 2 and x is equal to 7. Okay, so if x is equal to 7, so this is going to be the representation of 7, and n is equal to 2, so n minus 1, that is 1. Okay, so it is going to be 1. Now you can see one thing, that there is no 0 over here, right? So since there is no 0 over here, we can say one thing, that there has to be a 0 at the beginning, because 0 at the beginning has got no value. So we are going to just append this 1 to the beginning. So that is 1 1 1 1, which is 15. Okay, now if we take any other example, so let's take an example, any example. Okay, if we take any example, so what we have to basically do is, we have to replace all the zeros in this string with the digits over here, and in case the number of zeros in this string is lesser than the number of digits over here, that is in this case, since there was no 0 over here in the string, in that case there is an exception, that is you have to append it to the beginning, nothing more. Okay, so that's it from my side. Thank you.